Hi Year 12s, this is Mr. Lim here again. We're doing a video on oxidation numbers, the second video on the series for Redox. So let's have a look. Today we're learning about oxidation numbers and how to use them. So that means we have to be able to identify oxidation numbers of elements or compounds in an elemental state. Once you've identified their oxidation numbers, you should be able to work out whether they've undergone oxidation or reduction based on those oxidation numbers. Right, so let's go. So what are oxidation numbers? Oxidation numbers are arbitrary numbers assigned to elements to help us identify if oxidation or reduction has occurred in a reaction. Okay, so they're just numbers that we assign to elements. If an element has increased in oxidation number, it has said to be oxidized. Okay, so say you have a substance, let's call it XY, right? And it suddenly becomes XZ, okay? We have to work out their oxidation numbers. So if this one has gone from +1 and this goes to +2, right? Then it's said to have gone oxidation. Okay, so whatever that oxidation number, if it's gone up, it's oxidation. If it goes down, it's called reduction. Okay, now each element in a compound doesn't necessarily have to have the same oxidation number. Okay, so if you have Y here, this Y might have stayed as -1. All right, but just because this one stays as it is, just because this one is, because this one has changed, okay, because that one has changed, this compound is said to have undergone oxidation, okay, and we'll go through that more when you see some examples. So let's have a look. So we have to be able to work out what the oxidation numbers are of various elements in various compounds. Okay, so first of all, we have to follow all of these rules, which you'll have to write down. So first rule, the oxidation numbers of elements in their elemental state are 0. So what does it mean by elemental state? That means things like O2, okay, that's in its elemental state because that's how you would find a pure element in its elemental state, right? And so all of the oxygens, the two of the oxygens there, have an oxidation number of 0. Okay, Mg or magnesium, its elemental state is just magnesium, and it might have solid, that one might be gas. This one has an oxidation number also of 0. So any element has an oxidation number of 0. Okay, so that's the first rule. Monatomic ions' oxidation numbers are their charge. All right, so what does that mean? Say things like sodium chloride. Okay. Sodium chloride we know is made up of sodium and chlorine. Okay, so therefore their charge is their oxidation number. So what's the charge on this one? +1. What's the charge on the chlorine? -1. So that's their oxidation numbers if they're monoatomic ions or monatomic ions, which means they're single atom ions. All right, let's move on. Okay. Hydrogens in a molecule have an oxidation number of +1, unless they are special ions called hydrides, in which case they are -1. So let's have a look at this one here, CH4. Okay, so there are 4 hydrogens within this molecule of methane, all right? And each of those hydrogens has an oxidation number of -1. Each one has an oxidation number of -1, all right? We'll deal with what they are together in a moment, right? But all of them have an oxidation number of -1. Okay, just like in hydrogen in water, they all have an oxidation number of -1. Okay, these hydride substances are usually alkali hydrides. So sodium hydride, which is an unusual compound to have. Okay, so the sodium monoatomic ion, +1. The hydride here is -1. Okay, and usually you'll see a metal with hydrogen, you're like, that looks unusual. You should remember that it's a hydride, and therefore it's -1. Okay, let's move on. We have oxygen molecules have an oxidation number of -2, unless they are special ions called peroxides, in which case they are -1. Okay, so things like CO2, all right, both of the oxygens there have an oxidation number of -2. All right. What about something like O3? Do they all have an oxidation number of -2? No. they're going to have an oxidation number of 0. Why? Because it's an elemental state. Okay, trick question, Mr. Lim. What? Right, peroxides, you'll usually get the name like hydrogen peroxide or sodium peroxide. All right, you'll see that there, this is an O2 2- ion. All right, and each of those oxygens has an oxidation number of -1. Okay, and you'll usually get told that they're a special peroxide or something by their name and something like that. All right. Then lastly, this is the one that becomes a little bit harder. Oxidation numbers in molecules and polyatomic ions are additive, and the sum of all oxidation numbers will be the charge. So let's deal with, first of all, neutral molecules. Okay, so neutral molecules like something like H2O. Okay, so the oxidation number of the hydrogens is -1. Okay, but there are 2 of them, so there's going to be -2 there. All right, because there are 2 of them. Sorry, +1 and +2. Okay, the oxygens are -2 because this is not a peroxide. So therefore, the total of all of those oxygens is -2. When you add those 2 together, they equal 0 because this is a neutral molecule. Okay, let's try something else. That means we can work out the oxidation number of something like the carbon within this substance. So the hydrogens are all +1, but there are 4 of them, so they become together +4. We know that this is a neutral molecule, so this must equal 0. So the carbon, the one of them, must be -4. Okay, which means that the carbon there is -4. All right, so the one carbon has to create all of that -4, so therefore it's -4 as its oxidation number. Let's try another one. Okay, something like CH2O. Okay, so the oxidation number of the hydrogens is +1. Together they are +2. The oxygen is -2. Since there's only one of them, it's -2. We know that that is neutral because there's no charge on it. So therefore, the oxidation number of the carbon must be 0. And sometimes that can be 0 as well. Okay. Then let's do an ion. Okay. So let's do a sulfate ion. SO4 2-. Okay. So we know that the oxygens are -2. Right. There are 4 of them, so that makes it -8 in total. Right. We know that the charge is -2. That's the total charge, and that means that must be the total oxidation number. So this sulfur must be +6. And I should really put a plus sign here because they're additive. Okay, so it's +6 plus -8 makes -2. Okay, and that's +6 then. Okay, so when you asked what is the oxidation number of something, of an element, you need to find out its oxidation number of one element. So the oxygen here, it'd be one of the oxygens is -2. Right. Let's do one last example before we move on. Because we're already taking up way too much time. Cr2O7 2-. Okay, so oxygens here are -2. There are 7 of them, so that makes in total -14. Right, the overall charge is -2. So what must this value be? That value must be +12. Okay, however, since there are 2 of the chromiums, each of them must be +6. So if you are asked what's the oxidation number of the chromium there, it's +6. Let's move on. Okay, so this is a question from an exam. Rank the following substances in order of the nitrogen oxidation number. Okay, so let's have a look. Let's try them all. So let's do this real quick. Okay, I'm not going to say anything. I'm just going to write down what you would do to solve it. And you can look at it later on and work out what I'm doing. So this nitrogen here is +5. Okay. The next one, nitrate. dinitrogen oxide. Let's just do it here. I know. Okay, let's do it here. N2O. O is -2. What plus -2 makes 0? +2, +1. Okay, so +1. Right. What is next? HNO2. And so we have okay, what must that be? +3. Okay, let's do the next one. Okay, H's are +1, so in total they're +4. They have a +1 total. So what must this one be? -3, -3. And last one, N2, no other elements, must be 0. Okay, so from lowest oxidation number state to the highest oxidation number state must start with the NH4, so that's not that one, not that one. Right, then followed by the 0, so therefore it must be A. Okay, and that's how you would work it out. Okay, that's that. You can have a look at this again and work it out and ask any questions when you have them. So these questions are actually quite good, so we're going to finish off this video. Okay, so use oxidation numbers to demonstrate that this is a redox reaction where you have that particular thing, state which substance to oxidize and reduced. Okay, so we have a look at them, we can work out the oxidation numbers of all of them. Okay, so +1, that must be +2, plus what makes 0. Okay, so that must be -2, so that is -2 for the H2S. Okay, Cl2, elemental state, 0. H2O, +1, -2. H+, monatomic ion, +1, it's its charge. The SO4 2-, we did that already, it was +6 and -2. And the Cl- monatomic ion, -1. Okay, so let's have a look. What's changed? So we've had a change of this one here. Go from 0 to -1. Okay, and what did we say? If it reduces or it gets lower in oxidation number, that must be reduction. Okay, and what else has changed? This -2 here on the S has turned to +6. So -2 to +6, that must be oxidation. Okay, so the S has oxidized and the Cl2, or the H2S has oxidized, and the Cl2 has reduced. Okay, all right. And that's, you'd have to show that their oxidation numbers and the changes and stuff. And if you wrote that on the thing, that'd be fine. All right, and then this bombardier beetle making some cool stuff. Determine whether the hydroxyquinone, which is that one there, right, is reduced or oxidized. Use oxidation numbers to support your answer. So we'd have to work out the oxidation numbers of this stuff. So the oxygen is -2. Now let's do that in blue. The oxygen is -2. There are 2 of them, so it makes in total -4 in brackets. Okay, the hydrogen is +1, so that makes +6 in brackets. We know that this must be all equal to 0 because it's a neutral molecule. So therefore, the carbon must be in total +2. Okay, no, -2. -2. Okay, so 6 carbons must equal -2. So therefore, each carbon is equal to -1/3. Okay, so in general, each carbon, depending on what it's bonded to, can have a different number, but overall, different oxidation number, but overall they have a oxidation number of -1/3. Okay, then we have here the benzoquinone as the thing that it turned into. All right, so the oxygen's -2 again, making that negative 4. Again, it must equal 0. Hydrogens are positive 4 because they're each positive 1. And the carbons there must then be 0. Okay, and so there's 0 overall. Okay, so negative 3 to 0, that has gone up or down. That's gone up. So therefore, negative 1/3 to 0 is oxidation. And I've used oxidation numbers to support my answer. All right, that's it. Go ask questions when you have them.